Alright, so hands on top. Alright, so now what have you guys been talking about in science this week? So somebody tell me what they think a magnet is. Give me your definition of a magnet. Phoenix, what's your definition of a magnet?
Like a metal that attracts like other metals.
Okay, Sierra, what do you think a magnet is? Alright, somebody help her. Alright, what is a magnet? Give me your own opinion. Give me your own definition. Okay. Ty, what do you think?
An attractive thing.
Alright, so a magnet is an object that has a magnetic field, right? That attracts things to it, like iron, cobalt, nickel. So what do you think a magnetic field is? Somebody tell me what they think a magnetic field is. Carlos, what do you think a magnetic field is? Okay, what comes from a magnet? Okay, Peter, what do you think?
The space around it that is magnetic.
Very good job, because that's exactly what it is. Go look up, Peter. A magnetic field is a space around the magnet that attracts things to it. But, so everybody look at this magnet. Do we see the magnetic field?
No.
So that tells us that the magnetic field is what?
Invisible.
Invisible, right? Invisible. You cannot see it. So the magnetic field has two poles. Does anybody know what those poles are called? Don't yell it out. Does anybody, Charlie? North and South poles. And what happens? What? Just like Santa Claus. That's a good way for you to remember it, right? So what happens when the North and South poles, when you put them together, what happens?
They attract. Stop yelling out.
They stick. And good job. Very good
Raise your
job.
hand.
So what are some things that you think we use metals for? Or magnets for? What are some things that anybody, what do we all use magnets for? What are some things you think we use magnets for? Brady, what do you think?
Hanging pictures on our fridge.
Hang a picture on the fridge. Or, okay, Kai.
Like to pick up cars.
Yes, like those big machines. You're good. That's a good example. Yes, good job, Kai. Zoe.
To decorate the food.
Yes, that's what somebody just said. You can decorate your refrigerator. But what are some important things that we use magnets for? Important things. Okay, Brady, give me one.
A compass.
A compass. Good job. Move up, Brady. Phoenix.
If you build like a bucket of milk on the floor, you don't have to pick them up like one by one. Like you can use a
Good job, Phoenix. Good job, Ty.
to build buildings.
To build buildings. What are some things in hospitals that you think they use them in? What machines do you think they use them in?
What's
In hospitals?
I know what it is.
What's it called? Not a vending machine. Not a vending machine, but I get where you're going with that. What do you think, Kyle? What do you think it's called?
Go inside of it. It's like
Oh, you know exactly what you call it. Starts with an M. Not an X-ray, but starts with an M. It's initials. M what? Not M-A, but M what? M-R. Not A, but M-R. I, guys. M-R-I. So the MRI machine. Does anybody know what that is?
Because they have to take off metal from you because it's
Yeah,
one side
it's
is
your
metal.
body. It's your body.
It's like in
Right?
an airport
It's
too.
your body. So here's another thing that you guys should have known because you use a lot of them, like your headphones. Brady said a compass, like, and it helps keep refrigerator doors closed. So magnets are everywhere. We use them a lot. What are some places around the room that you think magnets are in?
TV.
TV. Okay. What do you think? What do you think, Charlie? That closet. Let's see what happens when we connect this to this. Does it say?
Another magnet.
Another magnet. Let's see. Let's see.
Let's see.
Let's see. What happened? What's happening?
They can't. They repel. The other side. The other side. They repel.
Good job, Ty. Picked up on it. Good job, Ty. Good job. Two more persons. People. Charlie and Kinley. Okay, everybody else have a seat. Go ahead, Charlie.
So this chair right here and right here.
Take this magnet, see if it sticks to it.
Okay, I'm
Let's see.
probably gonna be wrong.
Let's see. We're gonna test it. We'll test her theory.
Hello.
Just so that means it's not.
Alright, wait.
All right, come on. All right, come back. Come back. All right, guys. So what I want you to do, I want you to do.
Kelly's turn.
Wait a minute. Hands on top. Everybody have a seat in their chairs. I'm glad you're excited, but let's have a seat. Can we go back? Go back. So now what we're gonna do? I want you to listen to this video, and I want you to be able to tell me some things that we use magnets for, what were in magnets, and we'll see how much you can get right, but how much you can remember, right? Somebody look at my desk and get the remote. See, one person, not. Thank you. Okay, Sophia, go back have a seat.
Okay. Dad, get off my chair.
It should be loud enough, though. To turn off one light. All right, so I'm gonna go ahead and turn it to make sure you listen. Doesn't matter which one.
What is a magnet? For kids, do you know what these are? If you said magnets, you are right. Magnets are used in many places for many things. And today, we are going to learn more about them.
Somebody gave me that
So
example.
what exactly is a magnet? Magnets are pieces of metal, usually iron or steel, that are able to attract certain kinds of other metals. The force drawing objects to a magnet is called magnetism. And the area surrounding a magnet is called a magnetic field. Pieces of metal like iron or steel can be pulled to a magnet. This is called attraction. When this happens, the metal will stick to the magnet like glue. There are two ends on each magnet. One is called the North Pole, and the other is called the South Pole. Want to know an interesting fact? The North and South poles of a magnet are attracted to each other and will always be pulled towards each other when they are near the other. But the same poles of two different magnets will push apart or repel the other. Let's test this out. First, let's try putting two North poles together. Look at that. They are repelling each other. How about two South poles? They also repel each other.
All right,
Now,
so let me just notice, when they put two north poles and two south poles together, what happens? Just yell it out. Tell each other. So what do you think is going to happen when they put the opposites together? Let's see.
let's try putting a North Pole and a South Pole together. Can you guess what is about to happen? You are right. They are sticking together because they are attracted to each other. Cool, right? There are 3 different types of magnets: temporary magnets, permanent magnets, and electromagnets. Temporary magnets become magnetized when a magnetic field is present and lose their magnetism when the field is taken away. Like when you rub a magnet against another piece of metal, like a paperclip or a nail. Permanent magnets are made from materials like iron or nickel that are naturally or chemically magnetized and already have their own magnetic fields, like the magnets you use on your refrigerator. Electromagnets are created by running an electrical current through a coil with a metal core. The energy energized core creates a magnetic field, and when the current is shut off, the magnetic field disappears. An MRI machine is an example of an electromagnet.
Let him clean it up.
Electronics like TVs and computers also use this kind of technology. Magnets are used in many places for many things, not just to hang up your schoolwork on the refrigerator. They are used in speakers, computers, motors, doorbells, telephones, buses, and tools. They are also used indoors, by recycling centers, hospitals, and lots of other places. And here is one final interesting fact. The Earth's core
What do you think? What do you think they're going to tell us about the Earth's core?
It's a big magnet.
It's a big magnet. The Earth's core is a big magnet. Good job.
made of iron and nickel. So it creates its own magnetic field. Wow.
All right, I'm
These
gonna
are
wait a
pretty
minute. I need
awesome,
y'all to
right?
focus.
Now that you know more about magnets, let's test your new knowledge. How many types of magnets are there?
How many types?
3.
Good job.
Temporary, permanent, and electromagnetic. Fill in the blank. The area surrounding a magnet is called a magnetic
Good
field.
job.
Magnetic field. True or false? The Earth's core has its own magnetic field. True. What happens when two south poles of a magnet are near? Push apart each other. An MRI is an example of a which type of magnet? Electromagnet. Magnificent job, magnet mavens. Whether you're doing a
All right,
scientific
guys. So now what we're gonna do? We're gonna get through this, and then we're gonna do a quick experiment. A quick experiment.
I like that. The paper passer should pass them out.
Okay, put that up, sweetie. Put that up. All right, Tilda, come here, baby. Pass those out. So I need everybody. Brady. No, baby. You know better than that. That's not funny. You know better than that. Let's make wise choices. All right. So everybody, we're gonna get a paper. What's up there? Give me a second. Everybody get a paper. Everybody pull the milk out. Everybody got a pencil. Real quick. If you want to sharpen your pencil, go ahead and do that real quick. Everybody have a paper. Everybody should have a paper. Alright. Yes, you too. No? Alright, so need everybody to have a seat. So by the time I get to 0, everybody should have their pencil sharpened and they should be ready to go. 10, 9, 8, 7, 6, 5, 4, 3, 2. Don't need your help. 1. Alright, we're all ready. We shall be ready though, so let's get back to our seat. Alright, so everybody tell me what's the title of our paper. Exactly. Back to what they do. That's a text feature. You guys just learned about that. That's your title. And under here, that's our what do magnets do? That's our what? Subheading. Good job. So who wants to read my first paragraph? Sienna was the first thing I saw. Go ahead.
Magnets create a force called magnetism. This force can attract certain materials such as iron, nickel, and cobalt. Magnets can also push or pull on other magnets depending how their poles are aligned. And a magnetic field is the invisible area around a magnet where this force can be felt. The strength magnet is usually strongest as it's cold.
Okay, so what are some important things that we just learned from that paragraph? Magnets create a force called what?
Magnetism.
Magnetism. And what does that force do?
Attract.
Attract what?
Magnet.
What type of material? Iron, nickel, and cobalt. Good job. Okay? All right, who wants to read our next paragraph? Go ahead, Kyle.
Magnets are very useful in our daily life. They are used to keep refrigerator doors closed, power speakers and headphones, help doctors to inside the body with MRI machines, and help people find directions with compasses. Magnets are even used in trains and computers.
Good job. Good job. So, what are the things they said we use magnets in?
MRI
Refrigerator doors,
MRI machines.
MRI machines. What are some things that you guys use that you put in your head?
Refrigerators. Phones.
Headphones. Good job.
Speakers.
Speakers and compasses, right? So let's look at number one. We're going to fill in the blank together. It says magnets create a force called what?
Magnetism.
Magnetism. Magnets create a force called... I'm trying to trick you. I was trying to get you to second guess yourself. Good job. It is. It's called what?
Magnetism.
Magnetism. Good job. Number two. Magnets attract materials like what three things?
Nickel, cobalt.
I need everybody to say it. Cobalt and what else? Iron. So in those three blanks, I need you to write those three words because you never know what may be a phrase. All right. The invisible area around a magnet is called a what?
Magnetic field.
A magnetic field. Good job. The strength of a magnet is strongest at its what?
Pulse.
Good job. Pole. Good job. And what are the two names of those?
Magnetic. North and south.
North and south. Good job. One tool that uses a magnet to show direction is a what?
Compass.
Compass. Good job. Magnets can blank or blank on other magnets.
Attract or repel.
Good job. Attract or repel. Very good job. So I need to see everybody write this down. Go look at a couple of this. So everybody should have that written down and a name at the top of your paper. All right. So we're gonna go over again. Magnets create a force called what? Magnetism. All right. Put it on the board so we can make sure we got it. So number one again is magnetism. All right. Magnetism. Number two. Magnets attract materials like what? Iron, nickel, and cobalt. All right. Number three. The visible area around a magnet is called a what?
Magnetic field.
Magnetic field. Good job. Trying to hurry so y'all have time to do this experiment. Four. The strength of a magnet is strongest at its pole. Good job. Five. One tool that uses a magnet to show direction is what? Compass. Number six. Magnets can blank or blank on other magnets.
Attract or repel.
Attract or repel. Very good job. All right, we'll leave this on the board, but we're gonna keep rolling. All right. So now what you guys are gonna do? Everybody's gonna get a paper, but you might have to take turns with the magnets. What you're going to do is you have a magnetic racetrack. You're gonna have a magnetic race. So I need everybody to listen. All right. So what you're gonna do? Everybody is going to get a car. And on the back of your car, you're going to have a paper clip on it. Alright, so on your paper you have 4 questions. And at the bottom it says draw your racetrack below. So number 1 says prediction. How long do you think it will take to finish the racetrack?
5 hours.
Number 2, use a stopwatch or clock. How many seconds it takes to complete the race?
15 minutes.
3, observation. What did the magnet do when it got to the car's paperclip? 4, reflection. Was it easier or harder than you expected? Why? So what you're going to do, you're going to draw your own race car track in this box right here. card track and see how fast you can do it. Alright? So I'm gonna give everybody their on paper, scissors, pass them out for me. Let you pass out over there, Kelly, you pass out over here. And I'm gonna come around and give everybody their own little card and their own. If there's not enough cards, you might have to take time, but that's fine. You're not doing it partners. You're not doing it partners. You're gonna be. It's gonna be at your group, and you're gonna see how fast you can do it. It's not a partner thing, y'all. Just do it as a group. Y'all gonna observe yourself and each other. All right. Part for you. Part for you. Part for you. Part for you. You only do it with your group. Card for you, card for you, card for you, card for you. You draw your own track on your paper. See how fast you. I'm gonna give everybody the magnet. Card for you, card for you. Did you get a card? Card for you. Everybody, hands on top. So everybody should have a card. I'm gonna come around. You might have to share your magnets, okay? Take turns with the magnets. I'm gonna try to leave at least 2. The first thing you need to do is do what? Draw your race card track. So go ahead and do that. These are yours must came off. Whatever way you want to draw it, baby, it doesn't matter. You're going to, once you draw it, you put the magnet under it and you try to slide it. First of all, you need to draw your race card track. Try to draw your race card track first. Who has already drawn a race card track? You didn't get a card. You might have to share baby. Alright.
I'll take one.
And make sure your paper clip is on good. Yes, sweetie. What's up? Put it up there. Now, did I ask anybody to come over here and get one? Not yet. No, I have not. I'm coming. I'm making my way around.
Hey, what are you doing?
So you see? You notice how it's moving?
Yeah.
All right, Grady, here you go. Y'all might have to share your magnets. We don't have enough for anybody, so you guys have to share. See how fast you can get around, and I'm gonna put the time here.
No, I did
Y'all might
not.
have to share your magnets. We're short. Y'all gonna have to share these magnets, so take your turn.
3, 2, I caught second. I caught second. No, I caught second. I caught second.
No, baby, it's
So I finished.
all right, you gotta time yourself. I'm gonna put the timer on this. Everybody.
I said 5 seconds.
You
Ready?
might need to try different magnets. You might need to try different magnets. All right?
It's working.
I told you it works. Alright, I'm gonna put the 10-minute timer on it. I want you to time yourself, okay? Take turns.
This call is fun.
Alright, I'm putting the timer on.
Go! Wait, which part do y'all go? Which part do y'all go? I'm gonna call him at Eddie.
Who else needs to See how fast? Try different magnets. Like different magnets. Try that.
Magnet with
See? That's different magnets. All right, got 8 minutes. See how fast. Keep trying to see how fast you can go. You gotta put your car on your racetrack and then put your magnet under it to see how fast you can get it through your track. And I'm gonna see. I'm gonna check and see who's not around the track.
Yeah. Bro, I caught the paper.
Who does not have a magnet that works? Make sure you write your time down and answer all the other questions on your paper.
Right in the middle of the
I'm not sure, baby. Maybe just put like 240. Have a seat. All right. Make sure you answer your other questions too, guys. Once you get your time. Once you get your time, answer your other questions. We got 7 minutes left, but I'm probably not going to give you that much time. Probably we just like 5.
I got 5.
All right, hands on top. Hands on top. We're going to try that again. Hands on top.
That means stop.
Honey, everybody have a seat. Who hasn't gotten their car around their track? Guys at nearest table, share your magnet.
I did it.
All right, so we're about to talk about it.
You have to call you. You can take your answer.
All right, honey, everybody's attention up here. So, who wants to tell me how fast it took their car to get around their track? Carlos, how fast? 2 to 3 seconds. Okay, that's good time. All right, Ari, how fast did it take your car?
8.
8. Okay, 8. So you might have a different type of magnet. Kinsley, 2 seconds. Ty, how long did it take you?
Me? About like 1. I had this big magnet.
So you had the big magnet, so it helped you make up some time. Kai,
Like 5 or 6.
5 or 6 seconds. Lydia,
5.
5. Grady.
5 seconds.
Okay. Sienna,
5 seconds.
5 seconds. All right. So,
Took me 0.
how long did you think it was going to take you?
I thought it was gonna take me 5.
You thought it was going to take you 5. All right. Carlos, how long did you think it was going to take you? You thought it was going to take you 5.
10.
All right. Sienna, how long did you think it was going to take your car to get around the track? How long did you think it was going to take?
Probably about like 10 seconds.
3 seconds. Okay. Observation. So what did the magnet do when it got close to the car's paperclip? What did the magnet do? Phoenix. It made the paperclip move, so that means that it was something in the paperclip that did what? That was magnetic, that attracted it. Good job. All right, so was it easier or harder than you thought it would be?
Easy.
It was easier? It was easier than you expected?
Yeah.
Okay, so why did you guys think it was going to be hard?
Because it looks hard.
It looked like it would be hard. Phoenix, what did you think?
I think it was.
You thought it was going to be easy? Grady, what do you think?
Well, so I thought it was gonna take like 30 seconds, but mine was like really long.
But it didn't take that long. Alright, anybody else want to tell me? What about you, Charlie? Did you think it was gonna take long? Did it? It didn't? Alright. Good job, guys.
To get a good match.
Good job. So I want you to make sure you got your name or your papers first and last, and then I want Tilton and Charlie to go around and get my papers for me. Then I would like